This is part 2 of a series called Proving the Earth is Not Flat. In this series, I intend to demonstrate how anyone can prove to themselves, using simple observations and experiments, that the Earth is not flat. It is a spinning and moving sphere. In this part, we will look to the stars. But first, to understand the shape and movements of the Earth, we need to understand how it works within the context of the solar system and the distant stars that surround it. The nature of the Earth, solar system, and stars took many centuries to figure out. The Greek mathematician Pythagoras was the first to propose that the Earth was a sphere in the 6th century BCE, but it wasn't accepted by most of the world until the Middle Ages between the 5th and 15th centuries. So, flat earthers, you are only about 600 years behind the curve. Because we live on the surface of the Earth, we are limited to seeing it from our perspective. Or at least we were back then. So when our perspective is limited, scientists create conceptual models and test them against observations. If a model cannot explain all observations and experiments, you either modify the model until everything fits, or throw out the model and start over. The prevailing model in the Middle Ages was the geocentric model, with the spherical Earth at the center of everything, and the sun, moon, and stars revolving around us. And to the casual observer, from our perspective, that is what it looks like. But while the model explained many observations, it failed to adequately explain some of them. Most notably, the apparent retrograde motions of the planets. Copernicus solved that problem by realizing that the sun is the center of the system, not the Earth. And the heliocentric model still works to this day to perfectly explain all observations, measurements, and experiments. Also, the ultimate test of any scientific model is its ability to predict future events. Using the heliocentric model, we can accurately predict lunar and solar eclipses, conjunctions, planetary alignments, and many other phenomena down to the minute or second. This is how real science works. No flat Earth model has ever been able to explain all astronomical observations, let alone make accurate predictions. I challenge any flat earther to use your model to predict the next lunar eclipse. So let's see how our view of the stars fits with the heliocentric model, and compare it to the flat Earth model. In the heliocentric model, the Earth spins on its axis once per day. The axis is tilted about 23.5 degrees, and that tilt constantly points in the same direction as the Earth revolves around the Sun once per year. This tilt is the cause of our seasons, and the seasonal variation in the length of daylight. The stars around us are very far away, but all the stars we see without powerful telescopes are circling the Milky Way galaxy with us, in the same direction and the same speed, so they are essentially stationary from our frame of reference. It is this backdrop of stationary stars we can look to understand the shape and movements of the Earth, as I will explain. In the Northern Hemisphere, we look at the stars and we see star formations we all recognize, such as the Big Dipper, the Little Dipper, and Cassiopeia. But in the Southern Hemisphere, these constellations cannot be seen at all, and different star formations are seen, such as the Southern Cross and Centaurus. And some constellations near the celestial equator, such as Orion, can be seen in both hemispheres. This makes perfect sense for the spherical Earth. Northern observers are looking generally upward toward the North Pole, and southern observers are looking generally downward toward the South Pole and seeing different stars. The curvature of the Earth is what blocks the stars of the other hemisphere from view. To illustrate, these blue arrows represent the direction an observer in the north views the stars in the sky, and the red arrows are the direction of the stars viewable by an observer in the south. They intersect in the middle, but you can see how the shape of the Earth limits our view of the opposite hemisphere. In contrast, on the flat Earth model, the north is the center, and the south is a ring around it. The stars would have to be arranged in a dome shape over the flat Earth. In this model, it makes no sense that people in the north cannot see the southern stars, and vice versa. And it is particularly absurd that people in the outer ring can all see the same southern stars, but not the northern stars at all. There should be nothing blocking their view of all the northern stars. Also, consider that on nights when the moon is visible, we all see the same moon running across the sky, everywhere on Earth, and we see the stars behind it. This works perfectly fine on the heliocentric model. But when you look north from the outer ring of the flat Earth model, there is no logical reason you would not see the northern stars behind the moon. The moon is supposedly close by and circling above near the equator. And you would be looking northward with the moon near the center of the sky. But somehow the northern stars can't be seen? This is an insurmountable failure of the flat Earth model. And it only gets worse for the flat Earth model. The nightly rotation of stars is perfectly explained by the Earth's rotation on its axis. Every night, we see the stars rise and set overhead. They move very slowly, but if you watch for half an hour or so, you will notice them change positions, moving from east to west. In the northern hemisphere, you will also notice the stars to the north rotate counterclockwise around a central point, called the celestial pole, very near a star called Polaris. You can easily see this yourself. Look for the Big Dipper, and the end of the dipper always points to Polaris, a relatively bright star. With patience, you can watch the Big Dipper and the other nearby stars rotate around Polaris each night. This phenomenon is a favorite subject of professional and amateur stargazers, and you can find many long-exposure photographs and time lapses of it. In the southern hemisphere, when you look to the south, you also see stars rotate around a point, but they are different stars, and they rotate in the opposite direction, clockwise. There is a star named Sigma Octantis very near the southern celestial pole, but is not a very bright star, so it is difficult to see. This apparent spinning of the stars around a north and south axis is perfectly explained by the heliocentric globe model, as the spherical Earth rotates on its axis and our view of the essentially stationary distant stars rotates. The distant stars to the north and south spin around a point because we are seeing them over the spinning axis of the Earth. Depending on how far north or south you are, some stars stay above the horizon all night long. These are called circumpolar stars. But they are completely different stars in the north and in the south. How would this work in the flat Earth model? Well, to put it simply, it couldn't. In any flat Earth model, the stars would have to be arranged in a semispherical dome over the flat circular Earth, and Polaris would have to be in the center, and that would seem to explain what we see in the north. But south of the equator, the outer concentric ring in the flat Earth model, now you have huge problems. When you look to the south, in South America, in Southern Africa, or in Australia, you see the same clockwise spinning stars. Yet people in those three locations would be looking in three different directions when looking to the south. Yet somehow they see the same thing. Where could the southern celestial pole and the circumpolar stars be in this model? Are they in many places at once? No, it simply cannot work. Of course, not all three of these distant locations are all in nighttime at the same time, but two of them at a time are, and the celestial pole and circumpolar stars stay visible all night long and are always directly to the south. I know some of you are going to claim that it simply doesn't look like that in the south, and that all images of it are faked. I'm not asking you to take my word for it. You could go and see it for yourself. But I do recognize that it is not cheap or convenient to travel to the southern hemisphere if you live in the north, and I have never been there myself. But if you were to go, I am extremely confident you will see the southern constellations, such as the Southern Cross, and also you will see the stars rotating clockwise around the southern celestial pole. Why am I so sure? Independent confirmation. No scientific claim ever comes from a single observer or a single observation. Science demands that observations are independently confirmed. And in this day and age, you can easily get independent confirmation yourself by finding someone on social media that lives anywhere in the southern hemisphere and asking them what they see at night. Or find any number of independently produced videos of it on YouTube. Of course, people lie and videos can be faked, but if you pick people at random, there is no reason to think they are part of a conspiracy, especially if you don't tell them why you are asking. And the more independent, neutral sources you can find, the less likely it is that they are all wrong or lying. If the stars in the south did not actually appear the way they teach it in all the schools of the world, a great many people would have noticed it, as anyone in the entire hemisphere can look at the stars. There is no way to hide them. But no one, outside of a few flat earthers, have ever said the stars don't look right in the south. Nearly the entire population of the southern hemisphere would have to be in on a conspiracy, or somehow deluded, if the stars didn't actually appear, as people have been reporting for centuries. The Southern Cross is actually depicted on the national flags of 5 southern hemisphere countries: Australia, New Zealand, Brazil, Papua New Guinea, and Samoa. I'm not asking you to believe me. Either go there yourself or find multiple independent sources to tell you or show you what they see in the sky. Another thing we notice in the real world is that the stars that are near the celestial equator change throughout the seasons. We can see Orion in the winter. In spring, we see the sickle of Leo the lion. In summer, Scorpius dominates the equatorial sky, and the fall brings the great square of Pegasus into view. This is explained by the Earth's orbit around the Sun. The night side of the Earth rotates around, and thus our nighttime view points outward to different stars. There is no valid explanation for this observation in the flat Earth model, and this brings up a subject that confuses some flat earthers. They say if the Earth orbits around the Sun, why doesn't noon become midnight 6 months later? Why don't the day and night times reverse? The answer is that our system of measuring time already takes the orbit of the Earth around the Sun into consideration automatically. Noon is when the Sun is the highest in the sky, and the time from one noon to the next noon is divided into a 24-hour day. This is called a solar day. But because the Earth orbits around the Sun about 1 degree every day, the Earth actually has to rotate a little bit more than 360 degrees for the Sun to be directly overhead at the same place. A full 360-degree rotation in relation to the distant stars is actually a little bit shorter than 24 hours, about 23 hours and 56 minutes. This is called a sidereal day. So that's why noon doesn't become midnight 6 months later. And this orbit around the Sun explains why the stars we see at night near the celestial equator change throughout the year. The night side of the Earth rotates around, revealing different stars. There's one more thing flat earthers complain about regarding our view of the stars that I want to address. They ask, why does Polaris, and all the other stars as well, remain in the same place from our perspective year after year if the Earth is rotating on its axis and on a 23.5 degree tilt, and also revolving around the Sun, and also moving around the Milky Way galaxy? This is no problem at all when you understand it. The Earth's daily rotation on its axis accounts for the rotation we see in the sky and around the 2 celestial poles, as I've shown. And since Polaris is near the North Celestial Pole, it stays close to the same position. Also, as I already explained, all the stars we see with the naked eye, including Polaris, are revolving around the Milky Way with us, in the same direction and close to the same speed. So that will not cause the stars to change their relative position in our sky in the short term. Just like how other cars on a freeway moving with you seem to stand still. And one revolution around the Milky Way takes about 225 million years. So we are essentially moving in a straight line. With Earth's moving around the Sun, the Earth's axis stays pointed in the same direction in relation to the stars. And since Polaris is so tremendously far away, our view of it does not change noticeably. We're going to need some simple trigonometry to demonstrate this, but I'll use an online triangle calculator to make it easy. The latest estimate for the distance to Polaris is 323 light-years. This is an unimaginable 1.8 quadrillion miles, or 1.8 thousand billion miles. Our trip around the sun is only about 186 million miles, which is a tiny fraction in comparison. So, if we form a triangle from Polaris to the Earth, and over to the location of the Earth 6 months later on the other side of the sun, we can calculate the distance that Polaris will seem to move from our perspective. The change in its viewing angle. This is called its parallax. When we plug in the distances of all three sides of the triangle into this triangle calculator, we find that the angle we view Polaris only changes by, are you ready? 0.0000566 degrees. There is just no way you are going to notice that. This is why Polaris and all the other stars maintain their visual position year after year. They are just so tremendously far away. So we see that just looking up at the stars provides further confirmation that the Earth is a spinning and moving sphere. When you understand what you are seeing, and you understand how it fits with the heliocentric model. The heliocentric model is the correct model because it perfectly explains all observations, experiments, and measurements. Not because some government agency or secret society says so. Science works by observation, independent confirmation, experimentation, testing, and making accurate predictions, never by authority. And science is really open to everyone. Go out and look at the stars yourself and test the models against what you see. No flat Earth model can even come close to properly explaining what we see in the stars, or any of the other observations I discuss in this series. That's why it was thrown out centuries ago. Thanks for watching.